Welcome, student, to some examples of the limit. We will start with the first type of problems, which we call it eliminating zero denominator by cancelling common factor in the numerator and the denominator. This is where we will have to find 0 over 0, and the way we will do it is we need to find a common factor, something similar in the numerator, something similar in the denominator, and we will cancel them out. So let's start with the first example here we have. So here we need to find this limit. So the first step always before you try to do anything is you need to do a direct substitution. So we do a direct substitution. What do we mean by direct substitution? You see this number 3 here, we plug it instead of x. So if we do that, what we will get is instead of x, you need to write 3. So every x you see, you just write 3 and 3. Now find this in your calculator. What you will get in the top is 0. What you will get in the denominator is 0. And this is undefined. That means we need to do something in order to find this limit. There is something that has to be cancelled from the numerator and the denominator because we have a rational function. Keep in mind, that's the first thing we try. So if we look at the denominator, there is nothing to factor. It's x minus 3. This is just a linear. This is just one factor. But if you remember, we have x squared minus 9. And x squared minus 9 is something we know how to factor. There are some formulas, and I will remind you of this formula up here. So we have limit x goes to 3. We have x squared minus 9, x minus 3. So this would be just limit x goes to 3. Now we need to factor this one into two parts and keep x minus 3 as is. How do we factor this one? Based on what? Let me just zoom in here and remind you of the formula of two different squares. So if you remember, if we have a squared minus b squared, this can be factored easily into a minus b and a plus b. Now, what has this to do with our case? Remember, our case, we have x squared minus 9. And if you remember, 9 is just 3 squared. So this will be my a, and 3 will be my b. So what we will get x, because x is a, minus 3, x is b, plus 3. So we get x minus 3 and x plus 3. And that's where, just a reminder up here for you how we did it. So we will get x negative 3 because this is x is a and b is 3. And the same thing, but this is a different sign, which is x plus 3. Now, if you look at this one, this is straightforward, clearly, that we can cancel x minus 3 and x minus 3. So what's only remaining for us is x goes to 3, and then we have x plus 3. This is the only thing we have. Now, what we need to do next is we need to do direct substitution. So substitute x equal to 3. Do we get a number or not? And that's the most important part. So if we just plug x equal to 3, so we get 3 plus 3, and this is 6. Remember, this is a number. So we stop and we say that the limit is equal to 6. And that's how we solve this example. Let me go through it very quickly here. So the first thing that we notice here is if we do direct substitution, we get 0 over 0. This is just a checking step that we need to do something. And what we need to do, we need to factor the numerator, and in some cases also we need to factor the denominator. Now in this case, we don't need the denominator because it's only x negative 3, and that's straightforward. However, we have x squared negative 9, which we can factor it by using this formula here. A squared minus b squared, which is x squared minus 3 squared, will be a minus b, so it will be x negative 3, a plus b, which will be x plus 3. We plug in this here. Cancel, cancel. So what will next is only x plus 3, and that's what we get here. Now, if we plug in 3 instead of x, we get 3 plus a 3, and the answer is just 6. And 6 is a number, so we stop, and the final answer, if we just want to write it down here so you don't forget it, the final answer will be just equal to 6. And that's the first example up here. Let's go to the next example. We do the same steps all over again. We see what we can do. So in this example here, we need to find the limit. So as usual, we do a direct substitution first. Direct substitution. We get this limit. Y goes to 0. Now, if we do direct substitution, of course, we just need to substitute 0 instead of every y I see. I will replace it with 0. Of course, this you can do it very quickly in your calculator. Just check you get the same thing here. And every y you see, just plug in 0. Now, if you do this in the calculator, the numerator will be 0 over 0. And we know this is undefined, so there must be something that we need to do. What do we need to do? Directly, we need to try to see what we can do, what we can factor, what we can keep. So let's do that. So we have this limit. Y goes to 0. 5y power 3 plus 8y squared. 3y power 4 minus 16y squared. Now, the first step to notice in the numerator, there is common factor. We have y squared and we have y cubed. So here we have 3 y's, here we have 2 y's. We can take y squared as common factor. What will be remaining? I have 3 y's, I take 2, so it's remaining only 1 y. I have y squared, I will just add plus 8. In the denominator, we do the same thing. So we will get 3y squared minus 16. Next step, we need to cancel. So I will cancel y squared with y squared. And that will simplify my question. So you will get 5y plus 8 divided by 3y squared minus 16. Next step, we need to substitute 0. So you have, instead of every y you see, we need now to plug in 0. So here we will get 0, and here is 0. Now write this new calculator. Hopefully we will get a number. It is 8. So it is minus half. Again, this is a number. So we are happy. We stop. And the limit is negative 1 over 2. And that's the answer for this question. So the idea in this question only is to take the common factor. We see that we have y squared, y squared. If we take them as common factor, get cancelled. And remember, there must be cancellation. In order to solve those questions, there must be some cancellation that will happen in those questions.